Dear student, I welcome you all for this control system laboratory wherein today we will explain and understand and able to conduct using the kit which is available in our laboratory. Synchro, transmitter, receiver, pair, and we can able to plot the characteristics curve. So the synchrona is a electromagnetic transducer wherein primarily used to convert an angular position of a shaft into electrical signal. Neither it can be voltage or current based on the requirement. So primarily a basic synchrona is used as a synchrona transmitter which is of similar in construction of three-phase alternator wherein the stator will be laminated with silicon steel and slotted to accommodate a balanced three-phase winding which will be having a phase difference of 120 degree electrically apart. And the rotor is a dumbbell construction wounded with a concentric coils. The AC voltage is applied to the rotor winding through the slip ring. So the primary application, the synchronous pair as a humorous in the field of automobile, aerospace and etc. So primarily automobile you can observe the steering control of the automobile device. Moving on with all these basic prerequisites. So in today's session you can observe the objective, what is the apparatus required to conduct the synchronous transmitter receiver pair, circuit diagram and about the procedure, tabular column and the demo of the experiment, how you can able to conduct the kit. So I had prepared a small video wherein you can observe and you can able to simulate in line with it. So moving on to the objective, the student will get a sufficient knowledge by operating on synchronous transmitter receiver pair which is available in our control system laboratory to enrich their knowledge about how the transmitter and the receiver will work by just adjusting the angular position. So what are the apparatus required? So we must have a synchronous transmitter receiver set and the patch card to observe how the system behave. So this is our synchronous transmitter receiver pair which is available in our laboratory, and we do have a control switch for the overall kit to power on the kit, and we do have a switch for the transmitter and receiver, and these are the stator winding of a transmitter. You can consider as RYB or you can consider as S1, S2, S3 as the stator terminals are abbreviated as S1, S2, S3 according to the kit labeling I am telling. Similarly, the receiver stator terminal S1, S2, S3 and this is the digital voltmeter wherein if you want to measure the voltage between any two stator winding, you can connect across the and you can note down. So coming to the circuit diagram, so as I informed earlier, the stator winding of a transmitter and receiver will be energized with a three-phase stator voltage which will be having a electrically 120 degree apart the phase difference between all the three windings, and the rotor winding will be energized with the AC line for both transmitter and receiver. So here we need to observe how the angular position of the windings of stator winding, suppose S1 to S2 or S2 to S3 or S3 to S1, and you need to record that for each angular position according to the knob which has been provided for both transmitter and receiver. So why that voltage between the two winding is very important? Why I am telling, if the voltage what you are measuring, suppose with respect to S1 S2, similarly S2 S3, similarly S3 S1, should be a summation of other two line voltages. Okay, so that you can observe by placing a voltmeter across the terminals. So moving on to the procedure, you need to connect the supply cable or the patch cord to the knobs in order to record the voltage for the different phase angles starting from 0 to 330 degree. And initially you connect the stator terminal S1 S2 S3 with the stator terminal of receiver S1 dash S2 dash S3 dash with the patch cord. Before that, I insist you to record the voltages between S1 S2 S2 S3 and S3 S2. So now you can put the angular position of the transmitter at 0, then you can note on the receiver and tablet there. So this is the next set of procedure. Why I insist you is, I want to know what is actually the voltages between the two windings of the transmitter as well as the receiver for the different angular angular position wherein the user has to set it for different trials. And you can set it for the angular positions in steps by 30 degree to 330 degree and note on the angular both in transmitter and receiver. So you can observe that the rotor of a synchronous transmitter is rotated, the receiver also follows both the direction, hence the position are linear. With initial error will be there, error will be in terms of 0.5 to 1%, as the signal has to transmit from one place to another place, and also the identical motor what we will be designing for that also. So these are the two hindrance that you can get, even though the module what you will be procuring for the transmitter and receiver, there will be an error of 0.5 to 1%. So that is acceptable if you consider for any of the applications. And you can switch off the supply and bring back the position of the transmitter to 0. And you can plot for the different trials what you observe. So these are the tabular column wherein, as I insisted earlier, I need you to put it for the transmitter turn on and take it for the different rotor positions from 0 to 330 degree and observe the voltage between S3 S1, S1 S2 and S2 S3. Then you can turn on both transmitter and receiver, and whatever the transmitter angular position what you will be setting on, so the same thing you can able to observe in the receiver. So that you can observe in the demo session of the experiment which is followed next to this. So these are the ideal graphs about the RMS voltage of the stator winding of the transmitter for all three line to line voltages what we have taken, S1 S3, S2 S3 and S1 S2. So you can observe it is having a phase difference of 120 degree electrically apart. So this is the angular position of the transmitter and receiver. If you set it for 0 degree, the receiver also will be 0. Similarly, it will goes on. It is a linear curve. So then we will go on to the demo of the experiment. I hope you have. Good morning, dear students. So today we will see about synchronous transmitter receiver pair experiment, how we will be performing using the module which is available in control system laboratory. And let me give a brief information about this kit, and then we will carry forward how we can able to conduct this experiment using this module available. As you already come across the synchronous transmitter receiver pair, which is a electrical transducer, wherein whatever the signals what you are bearing with respect to the angular portion which will be converted into electrical signal, and this transducer will be inclined with the receiver also, wherein whatever the angular rotations wherein you will be rotating. So in line with that, the receiver also will move accordingly. So for that we need to validate the voltage across each windings. So that to the stator terminals, where you can easily identify S1, S2, S3. You can read as R, phi, B. Similarly, we do have a rotor terminal, so which is a single phase, and stator terminal will be of 3 phase. So now let me turn on the energize the power module, and let me validate the voltage across the stator windings. So this is the digital voltmeter, where you can able to note down the values of the voltages. So now the kit has been energized. So let me set to 0 degree initially, and this is the voltage what we received, that is 20.2 across S1 and S2. So similarly, now let me show you the reading from S3 to S1. So it is around 0 voltage, and let me make it clear. So this trial you need to note down for all the degrees starting from 0, 30, 60 and so on. Similarly, we need to record the voltage across S2 and S3 also. So this is the first trial what we have conducted for 0 degree. So now let me set it for 30 degree by slowly moving the transmitter angular position to 30 degree. Now you can energize the voltage across S2 and S3 is 23.5. Similarly, let me record between S3 and S1, which is 12.5. So in line with S1 and S2, it is 11. So again I can set it for 60 degree in the transmitter portion. So similarly you need to record the voltages. So that is 1.3 between S1 and S2. Similarly S1 and S3 it is 21. Between S1, S2 and S3 it is 19.6. So in line with this, you can able to continue for 90 degree. You can observe the changes in the voltages, 120 degree, 150 degree and 180 degree. Okay. So now let us see how the receiver behave also for the same angular position, which is set it for 0 degree. So now the student has to observe what is the voltage value which has been displayed in the digital voltmeter. It is 20.5. So now let me stop the transmitter angular position and change the terminal across S1 and S2 in receiver. So let me turn on the receiver now. If I set it for 0 degree, you can see the voltages value, which is almost similar to 21.9. So like this you need to validate for all the angular positions wherein you have recorded for transmitter from 0 to 330 degree at various terminal S1, S2 and similarly S3. Between the two line voltages you need to record, and you need to validate for receiver also. So now let us verify whatever the angular position, whatever I can able to set it in the transmitter, whether I can able to see the changes in receiver. As it is a synchronized pair, the angle what I will be setting in transmitter side will be in line with receiver. Okay, so you can observe here. So here the connection is as simple. So I have connected S1 and S1 of transmitter and receiver, and similarly S2, S2 and S3, S3. So let me turn on both transmitter and receiver. Now the angle is 0 degree. You can see the receiver angle is also 0. If I set it for 30, you can see the changes in the receiver also. It is 30 degree. If I set it for 60, the receiver is 60. and you can see there will be a little bit variation in the angle, so that is acceptable. That is the error that it will be creeping with the synchronous model. Now if I set it for 90, the receiver portion also will be inline, will be moved to 90. So you can validate for each angles starting from 0, 30, 60, 90, 120, 180 and to 330. Okay. So I hope you have learned how we can able to conduct a synchronous transmitter experiment using the module which is available in our laboratory. Thank you. Understood how we can able to do the synchronous pair of both transmitter and receiver by using the kit which is available in our lab.